Aaron has been offered a job to fill a barn with hay. How much hay volume can go in the barn? Okay, so we want to fill up this entire barn with hay. The entire barn. By the way, we don't have to pay attention to this. Who cares about paint? We're not painting it. That's going to be another question that we're going to have in the future. But for now, we don't care about paint. We're just filling up this barn with hay. We're at the total volume to fill up the whole barn with paint. Well, how do we do it? Well, there's two parts, isn't there? There's the roof. So the volume is going to be the roof volume. So let me draw that in real clear for us. Well, plus, let me just lay it out for the plus the box on the bottom, the box that is the base. So, okay, so we have a roof on top of a box base, and we just have to add those together. So let me show you. Oops, that wasn't so good. Okay, are you picturing that box? I mean that roof. Sorry, it's not the box, it's the roof. There we go. So there is the roof. So we want to find the volume of that shape first off. What is that? It's a triangular prism. Are you seeing it? Why is it a triangular prism? Well, because it's got two triangles, doesn't it? It has a triangle in the front and a triangle in the back. That's what a prism is. A prism is any shape where you have the same shape top and bottom, or in this case, front and back, because this one's laying on its side. So let's go down for a second and let's look from the notes. Here's the exam 3 notes. Volume of a prism. What's the volume of a prism? First off, what is a prism? See, here's a triangular prism. That's our roof. See, triangle top and bottom, straight sides in between. That's called a triangular prism. When you have the same shape top and bottom, or you can lay it down and be front and back, you know, two of the same shape, top and bottom or front and back, whatever, straight sides in between, that's called a prism. And we have a triangular prism for our roof. And how do you figure out the volume of a prism? Well, you find the volume of one of the layers and then just multiply by the height, right? Because all the layers are the same. It's triangles all the way down, isn't it? So if you can find the area of one of the triangles, then multiply by the height, you've got it, right? Look at the picture here. It's totally reasonable. You can find one of the layers, you know, there's 20, it's 4 by 5. So there's 20 cubes in one layer, then multiply by how many layers? High, the height, there's 4 layers high, 4 layers times 20 in every layer, that's going to be 80 cubes. That's the total volume to fill it up, of course. So you just have to find the area of the base times the height, whatever the base is. So that's what we have to do here. And the height is the distance between the two bases, isn't it? So if they're top and bottom, the height goes up and down. But in our case, the height is going to be the 87. Do you see that? Here's the height. It's going to be the 87 because it's the distance between the two triangles. So for that roof, which is a triangular prism, there's 2 triangles. Instead of top and bottom, it's front and back, but same deal. And the distance between those 2 triangles, what we call the height, is 87. So it's going to be area of the triangle times the height, right? You got to take the triangular base. That's how you find the volume of a prism. Triangular. And what's the area of the triangle? Well, area of any triangle we know is a half times base times height. Times, and what's the height here? 87, as we said. That's the distance between the 2 triangles. So what's the base and the height of that triangle? Well, you can see it right here. The base from there to there is 44, isn't it? And that's the base. And what's the height? The height is the 4 times the 87. So let's multiply that all together on our calculator. So I'm getting 7, 6, 5, 6. Now we still have to do the box base, but do you see what happened? Let me run over that one more time. So to find the roof volume, which is a triangular prism, right? Goes triangle to triangle. You got to take the area of the triangle times the height, which is the distance between the two triangles. And so that's 1/2 base times height, because that's area of any triangle. Base is 44. The height is 4 for that little triangle in the front there. His base is 44. His height is 4. Times 87, the height, we call it, between the distance between the two triangles. So we got that. Now for the box base, let's do our best to draw that. So I'm going to come in here and say, okay. Here. Go here. Go here. So there's the box base. That's the ground floor of it. Oops. Here's the top of it. Right, and then straight sides in between. My drawing gets off a little bit there. All right. So that box, that's another rectangular prism, isn't it? Do you see it? It's a rectangular prism. Okay, so now for it, again, how do we find it's the area of the base times the height. Now the trick is, for a rectangular prism, there's rectangles everywhere. So you can do whatever you want for the area of the base. Like, for example, I could call the ground floor the base if I wanted. Maybe I'm gonna do that. I'll do that. I can say this is the ground floor. I mean, this is the base. Right? There's the base. We'll call that the base there. So the base of this box is what? 44 by 87, right? 44 by 87. Times, what's the height? 33. Multiply those together on your calculator. And I'm getting 126, 324. So 126, 324. Add that to the other one. And I'm getting total volume of 133,980. Now, one last word about that rectangle. You might say, Mr. Aaron, wait a minute, you did for the triangular prism on the top, you did front and back for the bases. And then you changed your plan and did bottom and top for the rectangle thing. Yeah, for the triangle, for the triangular prism for the roof, we had no choice, right? There's two triangles. You have to treat those as the bases, right? Because the bases are what there's two of, and there's two triangles. There's only two triangles, right? For the triangular prism, there's only two triangles. You might say, what about this rectangle here? Well, there's actually three rectangles. There's the right side, left side, bottom. Anyway, I hope I'm not confusing you. You have to do the triangles. There's two triangles. Those are for sure the bases. But for the rectangle bottom, the box base, you could do the ground floor and the top as the bases, because there's two of those. Or you could have totally done the front and the back, like we did the triangles, and said, we'll use those as the bases. Yeah, that's okay. What would the front be? 33 by 44, times the height, 87. See, we just end up with those same three numbers, just in a different order. It doesn't matter. So when you come to a box, which is a rectangular prism, you have all kinds of options because there's basically rectangles everywhere. So you can do, you know, the rectangle on the front and the back. That's fine. 33 by 44 times the height of 87. Same thing. Or you can do the rectangle on the bottom and the top, which is 44 by 87, and the height is now the 33. That's fine. Whereas it'll work either way, you're going to get the same answer. Same three numbers, whatever order, right? Whereas for the triangular prism, no, there's only one choice. You have two triangles. Those are your bases. And the height is the distance between those triangles. That's the only way you can do it. That's the only thing there's two of, right? There has to be two of something when we do a prism. And those two of are the bases. And so there we go.